Hey, so for those of you who missed our review, I missed talking with you. It was kind of fun having everybody on together. Let's go through the 7 types of questions that you're going to see on this PC. Now, this PC is a lot about being able to just simply use the calculator. If you can use the calculator, most of this stuff you'll be able to figure out. So the first thing I'm going to do is I've actually given you a calculator to use on this assessment. So as you go into the assessment, getting ready to take the quiz, there is a blue calculator to use link to go ahead and open and use that while you are seeing it. Let me show you what it looks like. Let me see if I can show you what it looks like. The calculator will look just like this. So in this case, and I'm going to show you how to use it on this first one. The first question says, select all the numbers that are solutions, meaning they're exactly the same as the cubed root of 49. So I'm going to go ahead and hit this button right here, and I'm going to put the 3 there, and then I'm going to go to here, and I'm going to click 49, and then get my answer. Whoops. Back up a little bit. Let's try it again. As I see, it gave it to you just as we did it. Didn't even have to click answer 49, and there's my answer 3.65930. This is an irrational number because that number is going to go on forever and ever and ever. Never repeats. It's an irrational number. So now what we need to do is we need to plug in the rest of these numbers to see which of those are exactly the same. So since we have that one, we're going to go ahead and hit the next one. We're going to say, okay, this one says the square root of 49, and that answer's 7. So that's definitely not the same. Well, this answer is exactly the same, and it's not going to be as easy as that, so don't think that it is. And then this one, we already know that this is the answer I'm looking for, so this one is not right. Well, this negative just means multiply it by -1. So all that is simply going like this. Where's the negative sign? There should be a negative sign. For -1 times the cubed root of 49. Look, same numbers. However, there's a negative out in front. This is not the same. So in this if this were the case, this would be the only answer I would choose. Let's go to the next one. The next type of question will look like this. Remember, this is all about the Pythagorean theorem. Side A squared plus side B squared has to be the same as C squared. So we always want to think about, okay, which one's the longest one? In most of these cases, we've built them so that the longest one is always on the bottom. But don't always believe that because it's not always the case. So we're going to go ahead and square this, and square this. So we plug it into a calculator. And if you remember, the key to the calculator is using parentheses. We go back. There should be parentheses on here. Let's try it. Let's try the square root. Let's get rid of that thing that's there. So we want to square. We want the square root of 3. Oh, I knew there was parentheses. Oh my goodness, so much easier. So we're going to use parentheses. Square root, parentheses, square root, 3, parentheses, whoops. Square root of 3. and then square it. This is the squared, and we get my answer. It should be 3. Oh, it won't it gives you an answer. So in this one, you really don't want to use the calculator. You just have to remember that when you're squaring a number, it gets rid of that. Squaring the number, this goes away. So I get 3 plus 4. Squaring a number, the radical goes away, equals 7. So A is correct. B, 3 squared, 5 squared, 8 squared. So 3 squared is 9, 5 squared is 25, 9 plus 25 have to equal 64 because 8 times 8 is 64. This is not a right triangle. So now let's look at the last one. 2 squared, 4 squared, square root of 20 squared. Well, this is 4 plus 4 plus times 4 is 16. Remember, squaring a square root leaves 20. So A and C are the correct numbers on this one. Okay, let's go to the next type of question you're going to see. This one is as simple as using the calculator again. So we're going to go into the calculator, and it says it has to be equal to 7, but that 7 is going to repeat, so that means it's got to look like this: 0.1777777 all the way. Now, in a calculator, it has to round the very last number, so it should come up like this: 17777, however many sevens, and then an 8, because it has to round up. Okay, so we're going to plug in to our calculator all of the fractions. Don't stop at 1, but plug all of the fractions in. So I get 1 divided by 7. There's my answer. That's definitely not the same. Then I have 8 divided by 45. Look, just what I said, right? It someplace has to round to an 8, so this one becomes correct. And then the next one. So let's go to the next one. The next one says 17 divided by 100. Oh, that's 7 stops. It is not the same. No, no, no. And then 1 and 1/7, that means that we're going to, 1 times 7 is 7, so I get 8 divided by 7. But that 1 already told us it's too big, so we're going to not, I'll still plug it in for you to show you, but 8 divided by 7 is 1.412. So in this case, the only one that's correct is this answer. That may not be the case in all of them. You may have more than one answer, so make sure you're looking for more than one answer. Okay, the next one says, plot the square root of 6. In your answers, it will have a bunch of points labeled A, B, C, D, and you're going to choose the letter that matches the square root of 6. So the first thing we're going to do, there's like 4 of these questions, so make sure you go through them all. First thing I'm going to do is I'm going to go square root of 6. Oops, that was weird because that 8 divided by 7 didn't work. Square root of 6. My answer is 2.449. 2.449. So that means my answer is probably going to be somewhere in this area. So this answer could very possibly be B. The next one, another example. Oh, it's the cubed root of 66. So we're going to do the exact same thing. Cubed root of 66. And put the 3 out in the front. And then 66. Whoops, that was weird. Let's go back. Let's just get rid of that one. Cubed root of 66 My answer is 4.04. 4.04. So that answer is going to be it would have to have a point that would be someplace right in there. So that's the letter I would choose. Very last question. Oh, sorry, not the last question. Okay, the next one is find the length of this line. You're going to have to write the length of this line, not just choose it, I believe. If not, there may be choices to choose. But in this case, this is, once again, we're going to create Pythagorean theorem. So we've got to draw a right triangle. I'm going to draw that line up, draw that line over, and here's my right triangle right here. So the length of this line is 3. The length of this line is 1, 2, 3, 4, 5, 6. So that would be 6. Now we're going to square them. 3 squared plus 6 squared. That's 9 plus 36, which equals 45. But remember, that's the square. That's not the length. So we're going to take the square root to find the length. And in this case, I could write down the square root of 45, choose the square root of 45, or plug it in here to find out which one it is. Square root 45, and it's 6.708. This is also an irrational number. Anytime you take the square root and don't get a whole number, it's irrational. Okay, so in this case, the length is the square root of 45, so it would have been that box right there. Would have been that box right there. Okay, very last question. This is the one we struggled with a little bit on the last one. Let me go over it again. Okay, a rational number, we'll call it a rat number, is any number you can write as a fraction. I could write 3 as a fraction. It would be 3 over 1. I could write negative 4 over a fraction. It would be negative 4 over 1. This is a fraction, 7 over 8. This is a fraction, negative 9 over 7. Those are all examples of rational numbers. Well, let's look at the thing and see if there's any that look like that. Well, look, this one right here kind of looks like that. Okay, so there's one example. The next one is a rational number that is any number that has a repeat, that repeats. So in other words, 1.333 ... That 3, that ... that 3 means this number's 3, that number's 3, that number's 3. That is a rational number. Look, that one repeats. It's a rational number. Another one, look, 1, 6, 1, 6, 1, 6. That one repeats. It's a rational number. Another example of a rational number is one that looks like this, 0.47. There are no decimals. It's a terminating decimal. It's a terminating number. Terminating numbers are rational. Okay, last two. Let's look at these examples. First thing I'm going to do is I'm going to plug them into the calculator. So I get square root of 37, square root 37. Oh, look, it's not a whole number. That's an irrational number. That number is going to go on forever and never repeat. So that's an irrational. Let's try the last one. The last one says we're going to use that, and we'll do the cubed root of 99. And that, look, once again, it's a number that doesn't repeat, and it's going to go on forever. If it doesn't repeat, if you don't get a whole number out of a square root, it's an irrational number. Any number that contains pi is an irrational number. Okay, you guys, I want to wish you good luck on this PC. And we'll talk again on Monday.